Welcome to qnawire.
So for this problem, it asks us to find the frequency of light emitted for each of these transitions. So to do that, we'll start with the Rydberg equation, which is 1 over the wavelength lambda times the constant RH over, or times 1 over n1 squared minus 1 over n2 squared. So this is the Rydberg equation. However, we also know that lambda equals c over nu, which is the frequency, and the frequency is what we want to solve for in this problem. So we rewrite this equation so that the frequency equals the speed of light c times Rydberg's constant times 1 over n1 squared minus 1 over n2 squared. And so now that we can solve for frequency, we'll move on to letter A, which is an n equals 4 to n equals 3 transition. So we start with our same equation. Frequency equals the speed of light 2.99 times 10 to the 8th times Rydberg's constant, which is 1.0968 times 10 to the 7th, and then 1 over n1 squared, which is 3 squared, and then 1 over n2 squared, which is 4 squared. And the reason we have 4 over here for n2, even though that's our initial state, is so that this number becomes positive. And we already know that we're emitting this energy. We know we're emitting this frequency because the transition goes from a higher state, n equals 4, to a lower state, n equals 3. So when we solve for this, we get the final answer is 1.594 times 10 to the 14th hertz. And that's the final answer for letter A. Moving on to letter B, this time we have an n equals 5 to an n equals 1 transition. So we have our same equation, frequency nu equals the speed of light 2.99 times 10 to the 8th times Rydberg's constant 1.0968 times 10 to the 7th, and then we multiply this by 1 over 1 squared minus 1 over 5 squared. And when we solve for this, we get our final answer to be 3.148 times 10 to the 15th hertz. And that is the final answer for letter B. Moving on to letter C, this time we have an n equals 5 to n equals 4 transition. So again, we take our frequency equals 2.99 times 10 to the 8th times 1.097 times 10 to the 7th times 1 over 4 squared minus 1 over 5 squared. And when we solve that, we get our final answer to be 7.379 times 10 to the 13th hertz. Now we can move on finally to letter D, which is the n equals 6 to n equals 5 transition. And again, we take our frequency equals the speed of light 2.99 times 10 to the 8th times Rydberg's constant 1.0968 times 10 to the 7th, and then 1 over 5 squared minus 1 over 6 squared. And when we solve for this, our final answer is 4.008 times 10 to the 13th hertz. And that is our frequency for letter D.